Now next question. In the expansion of 1 plus a whole raised to m plus n, prove that coefficients of a raised to m and a raised to n are equal. Say, in the expansion of 1 plus x raised to n, general term is, that is r plus 1th term is NCR x raised to r. So if we apply this result, then here in the expansion of 1 plus a raised to m plus n, 1 plus a raised to m plus n, general term r plus 1th term is NCR. Say this number is n that we keep here. So what is here value of n? So it is m plus n. So we replace n by m plus n. So m plus n C r into x raised to r. So this is general term in the expansion of 1 plus a raised to m plus n. Now we want coefficients of a raised to m and a raised to n. Say here instead of x, here we take a. So x will be replaced by a. So here I did a mistake, keep here a. So this was x, so we keep here x raised to r. Instead of x, here a is given, so keep a raised to r. Now to have a raised to m, we have to put value of r m. So taking r equal to m, that means taking r equal to m, here m plus n c m into a raised to m. What is done here? R is replaced by m, and now because here we want a raised to n, in this equation we replace r by n, and replacing r by n plus 1 equal to m plus n times m plus n c n a raised to n. So here in this formula r is replaced by m and r is replaced by n. Now given that coefficients of a raised to m and a raised to n, show that coefficients of a raised to m and a raised to n are equal. So now coefficient of a raised to m, coefficient of a raised to m appears in m plus 1th term. So its coefficient is m plus n c n, m plus n c m. So it is m plus n c m, and coefficient of a raised to n is m plus n c n. Now say here we are using result. Result is, see this result I am using, NCR is equal to NC n minus r. So this result I am using in next step. So say this is in place of n. So NCR is equal to NC n minus r. So difference of these two number we keep here. So this is from this result. This result is used here. NCR is NCn minus R. So it is equal to M plus N Cn. And what is it? It is coefficient of A raised to n. So this is coefficient of A raised to n. So coefficient of A raised to m is equal to coefficient of A raised to n. So they are equal. Result is proved. The coefficient of r minus 1th, rth and r plus 1th terms in the expansion of x plus 1 raised to n are in the ratio 1:3:5. Find value of n and r. See, in the expansion of one plus x raised to n, r plus 1th term is NCR x raised to r. This is statement, common statement. General term r plus 1th term in the expansion of 1 plus x raised to n. Now here we are given, we need coefficient of r minus 1th term, rth term and r plus 1th term. So r plus 1th term, its coefficient is visible. So from this statement I am putting rth term and r minus 1th term. So what we do here, to get r minus 1th term, to get here r minus 1, I should replace r by r minus 2. So replacing here r by r minus 2, we get, now here see, I am replacing r minus 2. So r minus 2 plus 1, that is r minus 1. Similarly, same value here, I replace this r by r minus 2, r minus 2. And to obtain rth term, I replace here r by r minus 1 and replacing r by r minus 1, we get, now see here I am replacing r by r minus 1. So r minus 1 plus 1, that is r. So same here we do, r replaced by r minus 1. Replace r by r minus 1. So these two statements are obtained from this equation 1. So in equation 1, we are replacing r by r minus 2 and r by r minus 1. We are getting these two statements. So therefore, coefficients of r minus 1th term, rth term and r plus 1th terms are, see, r minus 1, r plus 1, r minus 1, r plus 1. So r minus 1th term, first we write this coefficient NC r minus 2, comma, coefficient of rth term. Coefficient of rth term is NC r minus 1 and coefficient of r plus 1th term, it is in equation 1. NCR. So these are coefficient of r minus 1th term, rth term and r plus 1th term. Given that these are in ratio 1:3:5. So here we are given that NCR minus 2 is to NCR minus 1 is to NCR is equal to 1:3:5. So that means, therefore, we can say that NCR minus 2, it is equal to 1 into K. NC, we say this is equation 2. NCR minus 1, I am putting in next line. See, from this statement, NCR minus 2, it is equal to K. NCR minus 1, it is equal to 3K, and NCR is equal to 5K. Because these are in proportion 1:3:5, so we can find K some natural number such that this is equal to 1K, this is 3K, this is 5K. So let me say these equations: equation 2, equation 3, equation 4. Now what we do, because we want value of n and r, we solve these equations. So first of all, I take ratio of 2 and 3. So from equations 2 and 3, LHS upon LHS, LHS upon LHS equal to RHS upon RHS. LHS upon LHS is RHS upon RHS. First of all, we solve this equation. We are going to get a relation between n and r. So here this k will be cancelled. So that means 3 times NCR minus 2 equal to 1 time NCR minus 1. Now we have a result that NCR is equal to n factorial upon r factorial into n minus r factorial. We know this result. NCR is n factorial upon r factorial into difference factorial. So here 3 into, now say using this formula, n factorial upon factorial of lower number r minus 2 factorial into, take difference of both numbers. So difference of these numbers, so n minus r plus 2 factorial, it is equal to, similarly on the right hand side, n factorial upon factorial of this number, factorial of lower number, then into difference factorial, so difference of these two numbers. So we have applied this formula. NCR is n factorial upon r factorial into n minus r factorial. So this is used in this question, in this equation. Now from this equation we simplify this equation. So when simplifying equation in last chapter, permutation and combination, whenever we have, suppose on one side, suppose here 100 factorial, this side suppose 98 factorial, then what we do, 100 greater, whatever is greater factorial, it can be converted into smaller. So 100 factorial we express as 100 into 99 into 98 factorial. Leave number with factorial symbol after getting the lower factorial which is on other side. So this can be cancelled. So same procedure we perform here. So here this is already same, so we are cancelling this number. Now 3 into 1 upon, that is 3 upon, now look these two numbers. In this two number, this is greater, 1 unit greater. So like suppose this is 99 factorial, this is 100 factorial. So the greater factorial we convert into smaller. So here this is for right hand side, r minus 1 factorial I express as r minus 1 into r minus 2 factorial. Go back. If it is 100 factorial, put this as 100 into 99 factorial, because this side we are having 99 factorial. So in the next step this can be cancelled. Then observe this number. This is n minus r plus 2 factorial, this is n minus r plus 1 factorial, this is one more. So this number we are converting into smaller. So it is n minus r plus 2 into n minus r plus 1 factorial. If it is 100 factorial, 100 into 99 factorial, because here we are having n minus r plus 1 factorial. So this factorial terms can be cancelled. So whenever we calculate with such factorial numbers, we can cancel by this method. Now whatever is left, numbers are free from factorial. So this number we multiply with 3. Therefore 3 into r minus 1 equal to 1 into n minus r plus 2. Therefore 3r minus 3 is n minus r plus 2. So this is n minus r minus 3r. So n minus 4r plus 5 equal to 0. So this is a relation between n and r. Suppose this is 5, equation number 5. Now to find value of n and r, we want one more relation. To obtain this relation, we have used equation 2 and 3. Taking ratio of 2 and 3, this is obtained. And now we are taking ratio of 3 and 4 by performing similar calculation. So from equations 3 and 4, LHS upon LHS equal to RHS upon LHS equal to RHS upon RHS. So this KK will be cancelled. Therefore 5 into NCR minus 1 equal to 3 into NCR. So now I require space. So first of all I am removing this part. See, from this equation, continuing 5 into, now NCR minus 1. So applying this formula, NCR is n factorial upon r factorial into difference factorial. So applying that formula, NCR minus 1 is n factorial upon r minus 1 factorial into difference factorial. So n minus r plus 1 factorial. It is equal to 3 into, again applying formula, n factorial upon r factorial into n minus r factorial. Now simplifying this will be cancelled. 5 upon here 3 upon. Now we perform procedure which we applied in a last step in getting equation 5. Say here, this is r minus 1 factorial, this is r factorial. This is greater. So convert greater into smaller. So r minus 1 factorial keep as it is. This number I convert as r into r minus 1 factorial. Now in this two number, this is greater, plus 1. So convert this in smaller. So n minus r plus 1 into n minus r factorial. Here this number n minus r factorial we keep as it is. So this factorial terms will be cancelled. So whatever is left, multiplying it 5 into r. So 5r is equal to 3n minus 3r plus 3. 3n minus 3r plus 3. So therefore this is 3n minus 8r plus 3 equal to 0. We say this is equation number 6. Now we solve equation 5 and 6. So for that, this equation, solving equation 5 and 6, this equation I keep as it is. Fifth equation I multiply by 2. So 2n minus 8r plus 10 equal to 0. So it is multiplied by 2. So taking difference, minus plus minus, subtracting these equations, this is cancelled. So n 3 minus 10 is minus 7 equal to 0. So n is 7. Putting value of n 7 in equation 5 or 6. Putting in 5, here n is 7. So 7 minus 4r plus 5 equal to 0. So 4r is 12. So r is equal to 3. Therefore n is 7 and r is 3. So this is final answer. Prove that the coefficient of x raised to n in the expansion of 1 plus x raised to 2n is twice the coefficient of x raised to n in the expansion of 1 plus x raised to 2n minus 1. Now see, in expansion of 1 plus x raised to n, formula for a general term is NCR x raised to r. This is a formula. Now from this formula I am putting expression in expansion of 1 plus x raised to 2n. Now n I replace by 2n. General term is replace n by 2n, so keep here 2n. 2n CR x raised to 2n. So this is sorry, x raised to r. So replacing n by 2n, here n replaced by 2n, this is general term in the expansion of 1 plus x raised to 2n. Now in 1 plus x raised to 2n, we want coefficient of x raised to n. Coefficient of x raised to n. So what we do? To have coefficient of x raised to n, we want here n. So in this equation, we replace r by n. So replacing r by n, so t n plus 1 is 2n cn into x raised to n. So that means therefore coefficient of x raised to n in the expansion of 1 plus x raised to 2n is 2n cn. Let me say this is result 1. Now we do for 1 plus x raised to 2n minus 1. So again, say in this statement, I replace n by 2n minus 1. So in expansion of 1 plus x raised to, now see what I do, n I replace by 2n minus 1. So n I replace by 2n minus 1. Replacing n by 2n minus 1. So in this statement, I replace n by, here I am taking 2n minus 1, so I should take here 2n minus 1. So in this equation, r plus 1th term is 2n minus 1 cr x raised to r. So this statement as well as this statement, both statements we have written from this rule, main formula for general term. Now look, now from this equation, because we want in the expansion of 1 plus x raised to 2n minus 1 coefficient of x raised to n. So to have here x raised to n, we replace r by, replacing r by n, we get t n plus 1, replace r by n. So wherever r is printed, wherever r is written, I keep r equal to n into x raised to n. So that means, therefore, coefficient of x raised to n in the expansion of 1 plus x raised to 2n minus 1 is 2n minus 1 c n. It is 2. Now we want to show that coefficient of x raised to n in the expansion of 1 plus x raised to 2n is twice, this is 2 times then this value. This value we want to show that it is 2 times that value. So what do? We take ratio of these two numbers. So now taking ratio 2ncn upon 2n minus 1 cn. Taking ratio, we can get a relation that which number is how many times, how much times the other number. So first number upon second number, it is equal to Now using here factorial formula, 2n factorial upon n factorial into factorial of difference of these two numbers. Factorial of difference of these two numbers upon again factorial of this number 2n minus 1 factorial upon factorial of this lower number into difference factorial. So 2n minus 1 minus n factorial. So simplifying this is equal to 2n factorial upon n factorial into 2n minus 1 is n factorial into, now here this is 2n minus 1 factorial, now this comes in numerator, n factorial into, this is 2n minus n is n minus 1 factorial. Now look here, this will be cancelled. In these numbers there is difference of 1 unit, and in this number there is difference of 1 unit. So greater number we convert into smaller. So it is equal to, see, 2n factorial we express as 2n into 2n minus 1 factorial, and this number I keep as it is. This number we keep as it is, 2n minus 1 factorial. This we are keeping as it is. This number is expressed as 2n into 2n minus 1 factorial. So in the next step this will be cancelled. Now look these two numbers. This number I am keeping as it is, and this number n factorial is n into n minus 1 factorial. So this can be cancelled. So therefore 2n upon n, it is 2. Therefore 2n cn upon 2n minus 1 cn is 2. Therefore 2n cn is 2 into n minus 1 cn. So this is twice the second number. So result is proved. Therefore result is proved. Find a, b and n in the expansion of a plus b raised to n if the first three terms of the expansion are 729, 7290 and 30375 respectively. See, first three terms are given. So say here, in expansion of a plus b raised to n, first term is, we know that first term is nc0 a raised to n. Second term is nc1 a raised to n minus 1 into b. Third term is nc2 a raised to n minus 2 into b square. These are first three terms in the expansion of a plus b raised to n. Now first term is 729. We say this is equation 1. Second term is 7290. This is equation 2. Third term is 30375. This is equation 3. So we have three equations. Now solving these three equations, we can get value of a, b and n. So first of all, I solve equation 1 and 2. From 1 and 2, LHS upon LHS equal to RHS upon RHS. LHS upon LHS equal to RHS upon RHS. Now NC0 is 1. This is a raised to n upon NC1 is n. This is a raised to n upon a into b equal to 1 by 10. So this will be cancelled. So we are getting equation, this a comes up. So a by b is n by 10. This is equation 4. We are getting ratio of a and b in terms of n. Now we take ratio of 2 and 3. Taking ratio of 2 and 3 from 2 and 3. LHS upon LHS. NC1 a raised to n minus 1b LHS upon LHS equal to RHS upon RHS. LHS upon LHS is RHS upon RHS. Now NC1 is n. This is a raised to n upon a into b upon NC2 is n into n minus 1 upon 2 into 1. A raised to n minus 2 is a raised to n upon a square into b square. It is equal to, now say here 7290 upon 30375. Numbers are divisible by 5. So 1 into 5 is 5, 4 into 5 20, 5 5s are 25, 8 5s are 40. So 1458 into 5 is 7290. Here dividing by 5, 6 into 5 is 30, 0, 6, 7 into 5, 35, 5 into 5, 25. Now divisible by 3. So 4 into 3, 12, 8 into 3, 24, 6 into 3, 18. Here 2 into 3, 6, 2 into 3, 6, 5 into 3, 15. Again divisible by 3. So 1 into 3, 3, 6 into 3, 18, 2 into 3, 6. Here 6 into 3, 18, 7 into 3, 21, 5 into 3, 15. So divisible by 9. 1 into 9, 9, 7 is left, 8 into 9, 72. Here 7 into 9, 63, 5 into 9, 45. Again divisible by 3, 6 into 3, 18, 25 into 3, 75. So 6 by 25. So this is 6 by 25. So therefore, now this is n, this n will also be cancelled. So see what is left here. Here a will be cancelled. Here 1b will be cancelled. So what is left here, this a comes in the numerator, a upon b, it is equal to, now see this will be multiplied on this side. So 6 into n minus 1 upon 2 into 25. So this number n minus 1 by 2 is multiplied on right hand side. So this is 2 into 3, 6. So A by B is 3n minus 3 upon 25. So this is equation number 5. So here also we are getting ratio of A and B. Now we compare value from 4 and 5. So from 4 and 5, n by 10 equal to 3n minus 3 by 25. So therefore 25 into n equal to 30n minus 30. So therefore 5n is 30. So n is 6. Value of n is obtained. Now putting value of n either in equation 5 or on 4, we can have ratio of A and B. So putting in 4, A by B is 6 by 10. So A by B is 3 by 5. So A is equal to 3 by 5 into B. Now this value and value of n, these both values we are putting in equation number 1. So putting value of n and A in equation number 1. Equation 1 is NC0. N is how much? 6. 6C0. A raised to n. What is A? 3 by 5 into B. Raised to n. N is 6. Equal to 729. 6C0 is 1. This is 3 raised to 6 upon 5 raised to 6 into B raised to 6 equal to, now 729, 3 into 3, 9, 9 into 3, 27 into 3, 81 into 3, 243 into 3, this is 729. So it is 3 raised to 6, 243 into 3. So this will be cancelled. So B raised to 6. Therefore, B raised to 6 is 5 raised to 6. So value of B is 5. So putting this value of B in equation number 6, putting in 6, A is 3 by 5 into 5. So A is 3. Thus, A is 3, B is 5 and value of n is 6. So these are required values.